All right, so students, it's important to understand that now we're going to be going over how to use data tables. And I bring this up because some of you will be, obviously a lot of you will be in other classes where you're using R, and you might not be using data tables. You might be getting the data as a data frame, or the professor might be going over it as a data frame. And when I show you these techniques, you'll be getting errors. So please be cognizant of the function I showed you guys here, the class function. Zoom in a little bit. All right, the class function. The class function, when you have a table of any sort, it'll tell you, hey, is it a data table or is it just a data frame, right? Or if it's just a data frame. And it's okay, right? It's okay. Most instructors don't care about how you do it. They just want the analysis. But if your professor or instructor cares about the end result being a data frame, it's okay. I showed you guys these commands for a reason. This will convert a data frame into a data table. This will convert a data table back into a data frame. So feel free to use data tables in all your classes. Just be cognizant of what you're working with. All right. So firstly, we're going to go over filtering data. Now, for those of you new to programming, these are what we call our logical filters, right? This, if you want to think about filtering, filtering is basically like when you have an Excel sheet, a table in an Excel sheet, and you want to filter some of the rows and certain column values by certain values. You'll use a filter command, right, or multiple filter. You'll use a filter command on one column or multiple columns, right, to filter one or more columns of values in columns, and you get a subset of rows that way. That is the same concept going on right here when we're talking about filtering, right? When we're talking about filtering. All right, so this is what these commands are essentially used for. Most of you guys are familiar with these commands. You know, this this one, greater than, less than, greater than, equal, less than, equal to. Now here you see a double equals. What's happening there? I've shown you guys what single equals means. Single equals means you're creating or transforming an existing or a new data container. Done. So what's double equal means? Double equals and single equals are completely different from each other. Nothing to do with one another. What double equals mean is double equals is a logical condition. It's basically used to compare two items to see if they're equivalent, right? Is 5 equal to 1? That's how you would see if two numbers or two values in a data container are equivalent to one another. For example, let's say I have the variable x equals 5, y equals 4, and I want to see if they're equivalent to one another. Basically, if they have the same values, I would do x equals y. And there you see I got a false Boolean that came up because they're not equivalent, right? That's what double equals mean. Again, double equals has nothing to do with what single equals is. All right, and there's also these other cool little functions here. Here, this ampersand means and. All right, so when you're building more than one condition, all right, think about, again, back to the example of the Excel sheet and multiple columns that you want to filter. This and is how you basically keep adding more conditions or more filters. Meaning this condition has to be true, and this condition has to be true, and this condition has to be true, etc., etc., etc. So this single pipe thing, and you guys will see this on your keyboard, it's a button you hardly ever touch, all right? Congratulations, you'll finally be using that button. This single pipe, this means or. So this gets a little more logically, a little slightly trickier. I'll show you some examples of where or will come into play. But this is a scenario when you need either a certain condition to be true or another condition to be true, or both can be true, right? See, and is when you have multiple conditions and all the conditions must be true. Or it's a situation where you have multiple conditions and at least one of them must be true. That's it. Just at least one of them must be true. So that is essentially the difference between and or. This is an exclamation point, and what this means is basically the opposite of any condition, and the opposite of any conditions, right? This basically, if you say, so if we go back to my example here, if this is x equals y, what if I want to test to see if x does not equal y? That's when I use the exclamation point. And this basically is saying, hey, hey, does x not equal? So 21 is asking, hey, is it x equivalent to y? Is the x value equivalent to the y value? 22 is asking, hey, is the x value not equivalent to the y value? True. They gave you true because they are not the same. So that's what the exclamation point does. The percent in, this is percent in percent. This is something really cool. This allows you to do multiple ORs, and I'll show you guys this in practice how this works. Is dot a is not finite. Is not finite. Now these are two different functions. All right. In R or in data tables, actually in R too, a null value is an NA value. So if you're filtering for all the quote unquote nulls in R it's NA, you would use the is.NA function, right? You basically want to say, hey, show me where all the NAs are, or show me all the rows that have NAs or nulls in a certain column value. Is.finite is basically asking, hey, you know what? Show me all the values that have some finite number, meaning they're not null, they're not infinity. Sometimes you could have an infinity value. They're not negative infinity. You could have a negative infinity value, right? So is.finite basically just says, hey, give me all the values that are actually numbers of some sort, or letters, numbers, values, but it's something of some actually value, not an NA, not an infinity, or something weird like that. So that's what these two functions are. Now here, what I'm trying to show you here is that there are three sections. So a DF right here, consider DF right here a data table. I call it DF, but consider that's a name of, pretend that's a name of a data container. That's a data table, right? And just like the vectors, you know, when we want to mess around with the data inside these vectors or data containers, we use the open bracket / close bracket, okay? Now, what's different from the vector I showed you, the simple vector, there are up to two main commas within the square brackets, right? Please don't confuse this from the other vector slicing I showed you, which was with the C parentheses, right? That's when we're selecting one position and another position that are not next to each other. These commas are not within the C function, they're directly within the square brackets. And they're used to basically define up to 3 different regions within the data container. And the reason for it is because those 3 regions are you're basically giving certain commands to the data container that are different from one another. For example, if there's no comma, then we're basically just talking about the rows. We're basically filtering the rows. Done, right? Simple. If there's one comma, then to the left of that single comma, where again is the region where we're filtering the rows. And to the right of that comma is the region where we are selecting certain columns, right? Because you can select certain rows and you can select certain columns within a table. So that's what's happening in that second region. And when there's 2 commas, again, the first section is the rows, second section is the columns. And then in this third section, to the right of the second comma, is what we call the grouping section. Now for my BAP students, this is basically the group bys that we talked about. For my new programmers, anybody that's ever done pivot tables, this is similar to what we do in pivot tables. For anybody that's taken MIS or any kind of database course, this is exactly like the group bys in our SQL. All right? This basically allows you to do commands or filtering on subsets of data. Subsets of the data. Not all of the data, but a certain sub part of the data and step-by-step parts. This will be more, this is actually, it's easier to understand if we have by example. So we already have our bike table. So using the bike table, let's say hypothetically, now we know from before that the season column has certain values, right? Has certain values. Here, let me show you actually a cool trick. If I do bike dollar, right? Just like with the list, all the columns pop up. All right, and from here, I can choose any column. So if we choose the season column right here, right, it basically gives you all the values from that column. Well, if we want a nice summary from all the values in this column, we have another cool function called unique. And I'll give you guys one guess what unique does. All right. Pass in the column from table in this unique function. And you see it's only 1, 2, 3, and 4. It basically, what unique does, it gives you all the unique values within a column. Or the unique values of any kind of data container you're giving it. In this case, we were giving it the column data from bike. And it shows us there's only 4 values, 1, 2, 3, and 4. And you guys remember from our previous slide, 4 basically means winter, right? So if I want to filter all the data, wait, was it? Let's just confirm that. Go back here. Season. Okay, excellent. So right here, winter is 4. So if I told you, hey, take this table, and I want you to filter all the rows of this table by only the winter ones, right? I know in season, my season column, I have all the different season values, and I know the number 4 represents winter. So I want to filter this by rows, right? I'm going to filter, I'm sorry, I want to filter the rows by the value of a certain column. This is the row section. This is what I mean by the row section. When we are filtering, when we're taking a subset of rows based on the value of one or more columns, or based on its value in one or more columns, then we're using the first section. And this is why we do bike season 4 right here, right? Bike season 4. Right, equals equals. Remember, we want it to be equivalent to 4. And as you can see, out of the data set we have, which is about 17,379 rows, 4,232 of those rows are from winter. All right, are from winter. Now, look at how this data came back to us in the data table. All right, now, firstly, what happened was you'll notice that the first few columns are up here: date, time, season, holiday, work date, weather, temp. And then the rest of the columns are down here: age, temp, humidity, wind speed, casual, registration, count. This is more of a function of your font size and the space down here your computer has, right? Let's see if I scroll all the way down, if I can get more of these to fit in here. No, so I think just the first columns, just one column didn't make the cut in the first row. All right, so that's pretty cool. Actually, let me actually minimize this for a second for you guys, just so you guys can clearly see what I'm talking about. Boom. And now you see that all the columns are in one go, as opposed to being cut off, right? Now, also notice that when you select these rows, I'm saying there's 4,232 rows. But in R, it doesn't give you the whole output. It literally just gives you the first 5 rows of the output you requested, and the last 5 rows of the output you requested. This 3 dashes dot 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 is basically implying that, hey, there's a whole bunch of data between these first 5 rows and these last 5 rows that we're not showing you. All right, this is no different than Spider in Python, when we're using Spider in Python, right? Both applications are for the purpose of data science. And as data scientists, right, just like before I explained this to my BAP students, you can only consume a certain amount of data in your mind. To R, they're like, why the hell am I giving you 4,232 rows when your human mind can't really do anything with that? So it's forcing us to be more disciplined. But nevertheless, as data scientists, right, as data analysts, we can clearly answer a question and say, you know what? Out of this table, we had 4,232 rows of winter, or 4,232 observations were from winter. All right, now let's take filtering a step further. Let's say I want to filter for all the data in winter and summer. Then what do I do? Okay, now in our English parlance, we would say I'm filter all the data for winter and summer. Right off the bat, you're thinking in your head, okay, I'm going to use the ampersand. I'm going to use this right here and say for season equals 4 and ampersand season equals 1. And you would be wrong. Okay? Why? First of all, let's go back and just confirm summer is 1. Oh, summer is 2. I have a typo here. I knew it, guys. I have a typo. Summer is actually 2. It is not 1. Just be cognizant of that typo. I apologize for that. That happens from time to time. All right. Now, back to what I'm saying. Here, we say winter and give me the rows that are both from winter and summer. The problem here is that in the table, the season column, you will never have a situation where in one row in the season column you have a value that's both 4 and 2, right? Again, this is a typo, it should be 2. That is physically impossible unless, of course, you're talking about quantum physics, right? Where one space can occupy two spaces at the same time. Going to the table back here, if I click on the bike table and we go down to the season, the season column, the values will either be 1, 2, 3, or 4 in any given row in this column, right? You'll never see a value that can be both 4 and 2. That is a logical fallacy. That is a logical fallacy. Therefore, how do we actually, from a programmatic point of view, actually answer this question? How do we get back all the subset data for both winter and summer? All right, we have to use the OR clause because basically we're saying, hey, give me all the rows where in the column season they have a value 4, right? Or give me the rows that have in the column season the value 1. If either one of these situations are true, that's what OR means. If either one of these situations are true, give me that row back. And that actually aligns exactly with what we're saying with our word. So give me both the rows, give me all the rows for both winter and summer. All right, and you guys can see this. And notice now, I got 8,474 rows, right? We know from before winter was 4,000 something, so it looks like about another 4,000 just from summer. So that's basically how the OR works. Now, I said before, I talked about the percent in command, right? So let's say we want to run that back. Let's say I want to say, okay, give me all the, and I apologize again, give me all the data for winter and summer. It should be 4 and 2, but just go with it, all right? I'm going to use the percent in command and percent command. Because what that allows me to do is, that allows me to say, you know what? Instead of doing season right here equals 4 or season equals 1, I can now say bike season percent in percent, right? And then I have to give some sort of vector. In this case, I'll give the vector, I'll just keep going with the notes 4, comma 1, or 2 for those of you guys that are doing it right? And this gives me the same results. Why? Because what this basically does is the same thing as this. This is basically saying, okay, go into the season column and grab all the rows that have either this value or this value. That's basically it. That's what this command is basically saying. Now, why is this cool and why do I use this so much more? Because let's say this is just over here in this situation, we're just saying, okay, find me rows where the column value is this or that. That's not a big deal. But let's say I'm looking for a situation where I'm saying, okay, find me rows where the column value is this or this or this or this or this or this. What if it's like 50 conditions? Am I going to write this 50 times? No. In this case, I just have to write the column name ampersand in and then give the column vector. Now some of you guys might be saying, hey, the column vector could be huge, but this is why I show you here is that you can predefine the vector outside of the data container. You don't have to create it dynamically in here like we did it. So in this situation, right, we can define the vector from before, right? And what I mean by define a vector, I mean basically, hey, write a vector that has all the values of the conditions you're looking for in a certain column of the data table, right? In this case, winter and summer. One is actually spring, but again, just go with it. And then I can use that vector, just like I did in line 30, All right, just do percent in, percent, put that vector in there, and it'll work the same way as 30. In 30, we dynamically created it inside the data container. In line 33, we used a predefined vector, right? But basically the same, it's the same results. All right, so here, run this, boom, same results, same results. And this is why I love using percent and percent. And for some of you guys, it's just more intuitive than using the pipe and those conditions. Now, let's look at an example. We're finally using the ampersand. We're finally using the and. All right, so in this situation now, I want to filter for rows that are both in winter and the weather was clear. Okay, now if you guys remember, the weather was the weather column was a different column, and just like before, it had numbers 1, 2, 3, and 4. A clear or good day was basically 1. So now we're using ampersand. Why are we using ampersand? Because now we want the conditions. We want all the rows that were in the winter, the season, winter time, right? But the weather was great. It was clear. Okay. This is why we used and, because both conditions must be true. It's not that just one condition is true or the other one. It's not like, oh, if the value 4 is in season, we're good to go, or the value 1 is weather, we're good to go. No, both values must be the same. I mean, both values must be true. Must be these values. The season column must have all the 4s. The weather column must have all the 1s. And give me all the rows where that is the case. That is why we use ampersand. Now, my BAP students, notice there's no parentheses. Remember how in pandas, when we were filtering multiple columns, right, and we're using the and or the or whatever, for every condition or every additional filter, if you're thinking about it from an Excel sheet point of view, you have to wrap those conditions logics up in parentheses, not in data tables. Data tables is like, yo, I understand it, I get it, no biggie, right? So again, that is why R is just a little more cleaner, clearer, and just slightly more intuitive. And you'll see that there's 2,609 rows where it was in winter time and the weather was nice, right? Again, I don't know how that makes sense, but we'll just go with it. All right, now, let's say, and this is where the exclamation point comes in, guys. Let's say we're going to filter for all the rows that are not in winter. So basically, give me all the seasons give me all the seasons except winter where the weather was clear. All right, this is where, again, the exclamation point comes in. Boom, boom, right? Exclamation point equals basically says, hey, give me all the values except for 4. So give me all the rows, give me all the rows that has a value that is anything but 4, and the weather column is 1, right? That's basically what's going on here. And as you can see, we get 8,000 rows back. We get 8,000 rows back. All right. Now, very important. Notice how we run when we run these commands, the data shows up in the console. A summarized version of the data shows up in the console, but nevertheless, data showing up in the console, right? But we could easily just take these results and place it into another data container. Basically, it would be a data table. It would be a data table. These results, whenever you take a subset of a data table is by definition a data table. So if I did no winter equals, we'll take this one right here, right? And I run this, notice this line now, there's no output. Why? 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 Single equals. Guys, right? Forget all the hoopla going on here between these square brackets, all right? That you're just simply selecting certain data within the data container, right? That's just in its own world. Once you have the single equals out here, right, outside of these data containers, it means the same thing again. You're creating or transforming an existing data container. And that is why there was no output here, just like with the vectors. Bam, we got an output there. And we just created a whole new table. Click on this bad boy, and there it is. You have a whole new table with a subset of data. All right, and that's how you can see And that basically answers your question, hypothetically, if you wanted to actually skim all the data when you're doing these sub-selections. You can just create a whole new table and put it there. In fact, that's, it's when you're creating these subsets of tables, it allows you, it's a better way to manage an analysis because it just makes things a little more concise and you're not wielding so much data. You're not wielding so much data. I teach an investment modeling class where the data just, towards the end of the semester, like more than half the laptops are breaking because the type of analysis and type of data we're generating is just so much from stock data that I show my students, look, just filter it, especially with the students that don't have as much memory. So, they have to use these filtering concepts and you deal with smaller tables to try to get the essence of the lab or try to do the same kind of analysis when you don't have that much kind of memory. All right, now let us discuss the column section now. All right. Now, hypothetically, let's say I wanted all the rows. Done, I wanted all the rows. But I wanted just the date time and the wind speed columns. All right, the date time and the wind speed columns. Now I'm going to use that first comma. Notice to the left, there's nothing there. All right, why is there nothing there and what does that mean? There's nothing there because I want all the rows, right? I'm not filtering by any values in a column. Give me all the rows. So that's what that means. When there's nothing to the left of the comma, that means everything, right? Likewise, if there was nothing to the right of the comma, that means give me all the columns. But to the right of the comma, there I am saying something. I'm stating here dot parentheses. Now watch this. Before, I show you the concept of C parentheses. In data tables, they use C parentheses in certain situations, and I'll show you that. But they also have the syntax of dot parentheses. This is strictly a data table thing. This is strictly a data table phenomenon. Now, what the hell does dot parentheses basically means? Anytime you're selecting more than one column, you must use a dot parentheses. That's basically what's happening here. So when I do dot parentheses, right? Notice I get all 17,379 rows. But notice at this time, I only get 2 columns, right? 2 columns. And again, that is why you must do dot parentheses. Dot parentheses are for when you're selecting more than one column. Now, all right, now, I can, if I'm selecting just one column, I don't need the dot parentheses. But notice the difference in the output, the way the output comes out at you. And there's a method to this. All right, there's a reason for this madness. Now if I just do wind speed, all right, I just got one column value, but notice how the value came back. Notice how the volume came back, the values came back. All right, let me scroll the way up. Here, no, here we go. So when I did the dot parentheses with 2 columns, boom, I got this data table output. It was very nice, first 5 rows, last 5 rows. When I do this, I'm getting all these numbers like this, right? What's going on here? You see, when you select one column without the dot parentheses, the results will come back at you for that one column, no problem. But it doesn't come back as a data table. It comes back as a simple vector. All right, it comes back as a simple vector. Why does it do this? Because there are situations where you just might need, a lot of times when you're doing certain kind of math or doing certain kind of analysis, you might want your results back as a simple vector to keep things clean. You don't want to keep using a data table because your output will be all functified or whatever, what have you. Sometimes you just need a vector of data to mess around with, to do some sort of vector mathematics with. Data table totally has built this concept in that, hey, you want the column of values in a simple vector to do some sort of math? Have at it. Take it. So when you just do one column, right, in the column section, and you don't have the dot parentheses, it comes back as a simple vector. Now, notice this back here. I remember I showed you guys, like, look, I want to talk about this. Notice these numbers. Your numbers you see, the one will, for most of you, will be not everyone will have the 1 first. This one over that I'm highlighting. Square bracket, 1 square bracket. But most of you are going to have a different number in the second row. And you're going to be asking yourself, okay, what's going on here? This is purely aesthetics. This is purely aesthetics. This has to do with whatever your font size is of R. This also has to do with how much space you're giving this window, right? So notice here, when I do these results, I get 1, 7 here. What does that mean? Basically, it's counting down for you which position these numbers are in. This 0 is the first value in my vector that I got back. Again, it becomes a simple vector if you don't have dot parentheses. This 0 is the 7th value. This 19 is the 0.0012, is the 13th value in my vector. This value, this number right here, 16.9979, is my 19th value, and so on, so on, so on. Look how this changes when you just mess around with the aesthetics a little bit. So if I run this again, all right, let me scroll back up, scroll, scroll. All right, now look what happened. So before I had 1 and then 7. Now, because I can squeeze in more values in each row, it's going by different, its cadence is different. It's doing it by 10. Again, the first one will be 0. This is the 0th value. This is 16.9979 value. This is the 16.997. I'm sorry. This is the 11th value. This is the 21st value. This is the 31st value, and so on and so on and so on. This is what these things mean down the side. This is what these things mean down the side. They basically help you eyeball, where a certain value is in your vector, right? It's pretty cool, right? That's the whole concept behind it. All right, now if you wanted your results back, if you just have a single column and you want your results back as a data table, you could just use a dot parentheses again. No biggie. Wind speed. Boom. See that? The results come back at you, but now it's not coming back as a simple vector. It's coming back as a data table. Okay, you have to be cognizant of that because you might just want to. You might want a subset of a data table because you want the features of a data table, or you might want a simple vector. Either way, you have the syntax there. Now, remember, if you want more than one column, you must use dot parentheses. You don't have an option there. You just have the option when you have a single column. That's it. All right, now, in the column section, by the way, another cool thing you can do is not only can you select subset of columns, but you can also apply functions on all the rows of that particular column. If I want to apply the mean, let's say I want the mean temperature for all the values. Bam. Right? I'll do bike for all the rows. Give me the mean. Remember, I'm calling the mean function. Now I'm calling the mean function in the column. I'm calling a function directly in the column section. Right? And I want for the temperature. All right. Fair enough. And it's, oh God, Celsius. It's 20.37 Celsius. All right. Fine. Cool. Now, get a little slightly fancier. Why am I typing this whole thing? I could copy it. Let's get slightly fancier. Let's get the mean temperature of just winter. Boom. Now you're seeing, using the filtering of the rows and the column section together, what you're getting. So 46 gave me the mean temperature of all my data for all 4 seasons. Line 47, now I'm filtering the rows. I'm basically taking a subset of the data and saying, hey, give me the mean temperature of just winter. Boom. 17.34866. Likewise, I could say, give me the mean temperature of summer. And summer, remember, guys, was 2. And it's 22.33. That makes sense, right? Summer is obviously hotter than winter. All right? So that's how you do these quick analysis. And also sanity checks. It allows you to do some sort of sanity check. All right, so that's what I call the function. I can obviously call multiple functions as well, right, in the function. If I want to call multiple functions, I just need to wrap it in dot parentheses, right? That's what I'm showing you guys here. Let's say I want the, all right, let's say I want the, what we like to say, the critical functions, right, the basic descriptors of any data. I want the mean, the standard deviation, the min, the max. Bam. It gives me those values. Now notice when it gave me those values, right? One, because I'm using dot parentheses, it gives me the results back as a data table. Done. The results came back as a data table. That's why you see that one column there. The strange thing here, and you're going to see this again, this theme coming up again, is these V1, V2, V3, V4. What the hell is that? It came back as a data table. Data tables have column names. In this case, once we're doing aggregation or taking summary of the data, R has no idea what the name of these columns should be, so it makes up its own column names, starting with V1 and going on, V2, V3, V4. Why V? V stands for variable. So basically variable 1, variable 2, variable 3, variable 4, and so on, so on, so forth. That's why you see this strange syntax over here when we did line 50. In line 50, we use dot parentheses, which forces a data table to be created, even if it's just one row. And that's why you have the one colon there, right? Signifying, hey, this is the first row. It's the only row. And that's why you have these these values, V1, V2, V3, V4, which basically signifies the 4 columns, right? All right. And like before, I can store these results in a table. So I can literally say, hey, you know what? Let me take this, store it in a table, right? And in this table, oops, right, I actually have this value, but I can rename, once it's a table, I can rename it. By the way, again, notice the BB's up there, right? B1, B2, B3, B4. But now that it's a table, I can rename those tables. Now, how do I rename columns of a table? So the simple way is, when you rename columns of a table, rename all of them all in one shot. I have 4 columns, and I'm going to go ahead and rename all of them. You have your single equals here, all right? Now, this is one of the few situations where you're going to call a function on the data container on the left side of the equals instead of the right side. And it's the names one you use. Use names, the data container that you want to change the column names to, and then using the C function, you basically give the names, the new names you want for each one of the columns. So the first one I know is mean, standard deviation, min, max, and that's why I did mean, standard deviation, min, max. Copy this over. So I have to change the quotes. When you copy from my slides, the quotes get all messed up. Some of the spaces get messed up and the quotes get messed up. So just be cognizant of that, guys. Here you go. I run this. Names run fine. It ran fine. If I click on BB again, you'll see that it's the same thing again, except now the new column names, right? And again, that helps when you're taking summary data and you want it, to have some sort of intuitive name behind it. Alrighty. Now, we finally get to probably the most powerful aspect of data tables, which is this grouping section, the third part. All right? That's what it's all about here, ladies and gentlemen. This is the group by concept from SQL. This is the pivot table concept from Excel. This is the essentially the group by command that they have in Pandas, right? And for those of you that have no idea what any of those things are, it basically allows you to apply analysis or apply these functions, slicing and dicing, by subsets of the data. Instead of doing it to the whole data set as a whole, you apply it to subsets. For example, remember before where I said here, what was the mean temp of winter? What was the mean temp of summer? Right now, let's say I want to do that with this bad boy. I want the summary information. All right, I want the summary information for winter. Right, and it gives it to me for winter. But let's say I want it for all the seasons. No problem. I could just write, I can just copy and paste and do all the filters. But let's say I'm looking at a piece of data that's not just it's not seasons I'm looking at, but I'm looking at some sort of column that has not 4 categories, subcategories, but let's say 40 subcategories, 400 subcategories. Okay? Am I going to type out 40 lines of these filters? Am I going to type out 400 lines of these filters? No. Programming is supposed to make our life easier, not more complex. enter the group by. This allows me right here, and finally we're using this third section right here, right? And again, please do not confuse this parenthesis or this parenthesis with any of these parentheses right here that are within the dot parentheses, right? Within the dot parentheses, you can have as many commas as you want. They don't have anything to do with the main commas that belong to the square open bracket, close bracket of data tables. Here is your main comma, first one. Here's your second one. The first keyword I put in there is by, and then equals, and then the column name. Okay? What is this saying? This is saying, listen, basically, group by, that's where that by comes in, this column. And what ends up happening here is a unique subtable will be created for every unique value in seasons. In seasons, we have 4 unique values, 1, 2, 3, and 4. Spring, summer, fall, winter. So what happens is once you introduce this bad boy right here, the third section, before it does any of the first 2 sections, before it does any of the row sections or column sections, this part right here creates 4 subtables. You don't see this. This happens back in memory. So these 4 unique tables are being created. Then to these 4 unique tables, these functions are being applied. And when you run this, all right, sorry, when you run this, let me do it right here. Oh, sorry, let me get rid of this filter. I'll get rid of this filter so it's for all the rows. And I do this, look at the results you get back. Now, you're getting a data table back. Obviously, you're getting data table back because you're using dot parentheses over here. Done. But notice now we have the 4 columns from before that have our values. Nice. But now we have this new column, season. That is because of the by right here, right? This is basically saying, this is showing you the results from each one of the subtables. This column is there to let you know, hey, I created subtables off the season column. There were 4 subtables there. These were the name of the different subtables. I'm sorry, these were the name of the different subtables, right? The spring, summer, fall, and winter. And these were the aggregations of those columns that you did here from each of these different subtables. It created the subtables. It ran this part, these functions on each subtable. It got those individual lines results, and it brought it back and gave you this output, right? That's why we get this output. We get this output because of what you're doing here and what you're doing here. The combination of the two gives you this output as a data table. All right, so what's the 3 steps of aggregation? 4 subtables, basically in this situation, 4 subtables were created, 1 table for each season. The functions were applied to each one of the subtables individually. So we got a summary for subtable 1, summary for subtable 2, and so on, so on. And in the end, the results were combined back into one data table, and that's what we see here. Now, let's say hypothetically we wanted to create a subtable, and this is going to be kind of crazy, but let's say we want to create a mean max setup for each season, and respectively each unique season and weather. So I want to see what the averages were for. I want to see basically what the descriptive or summary information was for winter when it was a clear day, winter when it was not so clear day, winter when it was a bad day, etc., etc., etc. Right? In this situation, I'm grouping by now more than one column. I'm grouping by more than one column. Now I'm grouping by 2 columns, season and weather. Because why? What's happening? What's going to happen here? What's going to happen here is you're going to have the subtables being created are now going to be a combination of the season unique values and the weather unique values. There are 4 seasons. There are 4 weathers. There are 4 unique seasons, 4 unique weathers. So basically, let's take, for example, when it's spring, which is 1 for season, and weather is great, which is 1 for weather. The unique subtable will be 1, 1. One for season, one for weather. That will be a unique subtable. So in this case, if there's 4 values in season and 4 values in weather, there's going to be 16 unique tables. There's going to be 16 unique tables, theoretically. Now, when you have more than one column you're using to do the group bys by, you must use, again, the dot parentheses, guys. See this? The dot parentheses are back in this situation. So in this situation, you have to use dot parentheses again when you have when you're grouping by more than one column. All right, and you'll get a value back like this. Let me show you guys this in real time. All right, I'll run this. Now notice, I said before, you should get 16 rows back. Why do we have 13 rows back? Well, let's see. We're getting 13 rows instead of 16. 1 and 1, 1 and 2, 1 and 3, 1 and 4. Nice. 2, 3, 2, 2, 2, 1. Okay, excellent. Here, there's no 2, 4. Guys, what does that mean? Right off the bat, this is telling us that when the weather is 2 is summer. There was no bad weather for summer. See that? There was no bad weather for summer. Summer only had good days, not so good days, rainy days. It did not have this bad weather. 4 means basically heavy snow and stuff like that, or heavy rains. Summer didn't have that. All right? Our data is telling us that. And now we know. Also down here, fall did not have really, really bad days. Winter did not have really, really bad days. It was just spring. Spring had really, really bad days. Not even winter did. This doesn't really make any coherent sense. But what this does is this allows us to generate more questions, which is what data science and data analysis is about. When you're doing data analysis, or whatever these terms are called, data engineering, whatever, the idea is to generate questions. Looking at the data, summarizing the data, slicing and dicing the data, generating questions from the data. So the data itself is generating questions. So what's data? What is this when we do this summary? What questions are being generated? Why the hell was there only bad weather in spring in this data set? Where is this data set? What region is it from? That's the heart of data science. You cannot do data science if you cannot ask questions. The right questions. Well, not necessarily the right questions. If you can't generate well, yeah, basically that's it. If you don't generate the right questions when you're doing data analysis, you're not doing data analysis. That is what it's all. I mean, if you can get the right answer, that's a different issue altogether. Are you asking the right questions? That's what it's about. All right. So here, just like before, guys, we can take this stuff and we can put it into a separate table. We can change the name, and now we can change the order of the data, right? This might be easier to see if we order the rows properly. So here, I will take this, store it in a new table, right? And by the way, I want to point out again, you still have those 4 V1s, V2, V3, V4s, right, from these aggregations. But because we have now 2 columns we're grouping by, you have those 2 columns here, season 1 and weather, respectively. Because this is first and this is second, you have that first and second, right? This is why you have this kind of output again. Now we create the DWS table, and what we want to do is we want to order our season and weather, right? How do you order? How do you change the order of a table? You use the order function within the brackets. And what this does is the order function is basically, by default, it's ascending. So here, if I say, hey, order by the ticker column first. Oh, I'm sorry, this is a typo. Ticker and date. I have a typo here, guys. This is from investment modeling. Apologize. Here, let me grab this. Wow, 2 typos. 2 typos. Sloppy. So let me write this down here. All right. And let's do this right now. So what do I want to order, boy? Firstly, I need the right column names. Let's do that. Let's take this. Oh, gotta change tickers. These things are wrong. So let me fix this. So I created the BWS table. And now I'm changing the column name so I know what I'm working with. Ticker and date. Get out of here, man. This is season and weather. Excellent. All right. And now I'm going to change the ordering. So I want season first. And then within the seasons, I want it in order by weather, right? And I do this. And if you look at BWS now, guys, right, you'll see, all right, it's ordered by the seasons first. And then within the seasons, respective seasons, ordered by the weather. 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, and it's easier to see. And by default, that's ascending order. Now, I ask you guys, how, if you wanted to make, do I show you guys here? No, I don't show you, right? If I wanted to do a descending order, anybody take a guess how you would do that? You would basically just add a negative. If you want to do it in descending order, so let's keep seasons as is, but I want my weather now to be in descending order. You just do a negative before it. It's strange, I know, but that's basically how the order function does ascending and descending. All right, so I do this. Boom, I ran it. Now if you do BWS again here, you'll see. All right, again, seasons in ascending order, and now weather within the seasons are in descending order. 4, 3, 2, 1, 3, 2, 1, 3, 2, 1, 3, 2, 1. And that's basically how you do ordering, right? So there's cool different. So I wanted to throw that in there so you guys had the ordering ready to go. All right. Now, what if you have your table, you're dealing with your table, et cetera, right? Let's say we want to essentially, instead of creating new columns or taking a subset of data, but let's say we want to actually, or selecting tables. Let's say we actually want to create new columns, right? So let's say hypothetically, we want to create a new column called season average temperature. That is basically the average temperature for the whole data set, but not by the whole data set. We want to do it by season. All right. Now I'm going to do two things. I'm going to create the original one right here. So let's do bike, all the rows, and I'm going to say average temp, right? I'm going to do it for all the values, just so you guys can see the difference, right? Boom. Note, look at the syntax, by the way. When you create a new column, firstly, again, it's in the column region. Secondly, this is different. It's not a single, you still have that single equals there, yeah, definitely. You're creating a new column in the table. But you have a colon there also. The syntax within data tables, and again, this is just a data table thing, guys. When you create a new column within the table, it is colon equals. It's not equals. It's colon equals, and that allows you to create a column within the existing table. If I click on bike now, right? If I click on bike, all right, when the new column is created, it goes all the way to the end. You have a new column there called average temperature, and I did it for all the data set, right? And it filled it in for each and every row. It's the same value because listen, it's when you take the average of a column, it's just one value. But because we're creating a new column, that single value gets repeated on every row. So this is the average temperature for every row. All right. Now let's say we wanted to create a new column, and now we're getting to the heart of what I'm talking about here. Let's say I wanted to do it for each season. I want to create a new column called season average temperature, just like I did in line 64. But this time I want to do it by season. Again, the group by comes into play. What happens here is subtables are created by seasons. The mean temperature is calculated for each one of those 4 subtables, the 1s, the 2s, the 3s, and 4s. It's calculated, and a new column is created in the subtable. A new column is created in the subtable. called season average temperature. So each subtable now has a new column created that's basically the average of that subtable. And that new name of that column is season average temperature. After all that's done, what happens? It brings back the subtables again all together. It brings back the subtables all together, causing, right? And here, I'm going to take advantage of these functions that you've never seen before called head and tail. I'll give you guys one guess what head and tail do. That's right. Head and tail basically allows you to see the first rows, X amount of rows, and the bottom X amount of rows, right? So if I did head bike 10, we can now see right down here, I have my average temperature, I have my season average temperature, right? It's a different value. Why? Because this is going to be for all the ones. In this case, it's for all the ones. So they seem like they're all grouped by together, right? And if I do the tail, right, this is the last, for this row, this is going to be the last 10 rows. Oh, again, I have all the seasons, right? I have the season 1. So let's do, let me just filter this. Let's do all the columns, right? All right, notice this is for winter now, right? It's going to be for winter. 17, it's a different average temperature. So it's going to be different, there's a different average temperature. Notice the average temperatures again for the whole data are the same, but for each season they're going to have a different season average temperature. Even though they repeat for that particular season, that's fine. But from season to season they change, right? And that is another example of the power of the group by. All right, and now we can apply filters if we wanted to. We can say, let's say hypothetically, we're like, you know what? Let's create a subtable in situations. Let's just see all the days where the temperature was less than the season average. So for each particular day, if the temperature was less than the season average, I want to see that. And that's how, ladies and gentlemen, we would do some more analysis, right? We would isolate the days now where the temperature of those individual days was less than its season average. And this is how, again, we use the logic to create a subtable. Okay? And in this case, again, in this particular example right here, down here, let's say hypothetically, I showed you guys how to create a new column, right? But let's say you wanted to create multiple columns at once, Now here, okay, so here's one of the few situations where R gets a little loopy. It's not as consistent. In this case, if I want to create more than one column, so this part is fine. The group by season, that's fine. I want to create a new column that has the mean temperature and the minimum temperature. Again, that's fine. All right. But when I'm creating these two new columns, I have to wrap these two new columns in a C function, and I have to put them in quotes. Let me put them side by side, right underneath the other, so you can see it clearly. All right, fix this. By the way, the capability of being able to manipulate these windows so fast is great, and so much smoother, by the way, than Spider. For any of you guys messing around with this, I mean, Spider is the same concept. It's just smoother here on RStudio. All right, now here, remember, we did the group by seasons. That's not a problem. We created a new column called season average temperature, took the average mean. But let's say we want to create two new columns. We want to create a new column which is the mean temperature and the min temperature, right? And we want one to be obviously the mean temp to be season average temperature and the min temperature season min temperature. So in this situation where you're creating more than one column off aggregations, again, anytime you have more than one aggregation, you got to have the dot parentheses, right? You saw that before when we were doing it up here in line 58, line 56. That shouldn't be new. The weird thing here is we're doing the colon equal, so that is consistent with line 70. What's inconsistent is when I'm selecting the two columns, I'm not doing dot parenthesis. This is a weird hiccup of an R. When I'm creating more than one, when I am creating more than one column within the data table, I need to use the C function, and then the new column names must be in quotes. Anytime you use the C function, you got to have for columns, you got to have those column names in quotes, right? In quotes. So when I do this, all right, you do this, and now if I do, let's just do tail by 10. All right, boom. You have the season min temperature, season average temperature. So the multiple columns are created. So this I wanted to show you just a little inconsistency and how it works. All right. Okay. Now the shift function. Now the shift function. This, ladies and gentlemen, we don't use the shift function that much, but this is a very powerful weapon in data tables. And for those of you guys taking business forecasting or any other kind of time series classes where you're shifting across time or across across rows, doing analysis across rows of the data as opposed to across the columns, this is very powerful and it's fantastic.